So welcome to this session. We are going to talk on how automate everything with metadata to build almost automatically our data warehouse. Just a little bit about myself, for who didn't came to the workshop in the first day. We already talked a little bit about automating things. I really love automating things. And so, for who weren't there, my name is Davide Mauri. I came from Italy. You may have understood it from my accent. I'm working from quite a few times right now with SQL Server, and especially in the business intelligence field. And I'm SQL Server MVP, president of the SQL Server Italian user group. I'm a solid Q guy, and you can find a lot of the things I'm going to talk about this day in my blog. And I also do some tweet, not that much, but I'm trying to get better in socializing with these new technologies. So now, before starting, just let's take a look at how we do build data warehouses today. At least this is what happened in Italy. Maybe you have different option, but unfortunately, it's still almost a manual process. I mean, if you have to start from zero, you have to do everything by hand. There are no, tool or things that can be really used to say, okay, I just automate a lot. And the truth is that it's a lot of repetitive work. You always do almost the same thing. For example, creating a dimension, loading a dimension is almost always the same thing. You just change the names of columns, of tables, but theoretically and logically it's always the same thing. So the problem is that there are very few tools available, mostly because there are no standards in the market. So one can just follow the standard and hit a button and say create a dimension or load that fact table, and that's it. Now, how I would like it to be, or probably, and you can tell me if you agree or not, I would like to have a semi-automatic process. I would like to say what I want, and I would like to have the machine do the physical process of doing things. Just imagine something like that. Wouldn't it be nice? I mean, create dimension, and that's it. Or alter dimension, add attribute, and all the stuff behind the scene, changing the ATL, adding the physical column to the table, in my opinion, should be done automatically, because there is no value in that. Of course, we still don't have such kind of special language, but we can figure it out how to do, maybe without creating an entire language, but from a logical perspective, do something very similar. So I would like to simply define the mapping logic or define the semantic of bringing the data from the source to the destination, so from my source ERP system or whatever to my data warehouse, and simply, say, this is a dimension, these are the columns for that dimension, this is the column you have to use to look up the dimension, this is the column you have to use to join the table, the fact table with the dimension table, and that's it. So I would simply like to create a metadata repository where I can store all the information about mapping, logic, and whatever, and leave the system to build everything for me. So with this in mind, one can wonder why this could be important. Well, because I really believe in Agile BI. For Agile BI means that if this is the vision I have about BI, we talk about this vision in the workshop with Thomas also, and as you can see, it could be somehow complex. And unfortunately, to do Agile BI, we need to do a lot of iteration, because I would like to deliver value as quicker as I can. So just after 1 month, let's say 10 days, 3 months, depending on the size on the project you are working on, I would like to start to deliver something. As soon as I start to deliver something and people start to use it, I must be able to accept the changes that they came and asked to me, because of course, as soon as they start to use my tool, they start to give me feedback. And I have to incorporate the feedback inside my process in order to make my process and my solution evolve with them. So as soon as I start to give something to the user, I should expect changes to happen. So the key word is embrace changes. But in order to embrace changes, we must have a process that is so cheap to be done that allows us to embrace changes really. Otherwise, it will be simply too much expensive. So since we want to do as many iterations as possible, so just imagine delivering a new version of your data warehouse or a BI solution every month. This means that in these 30 days you have, well, actually 20 working days, you don't really have to lose your time in doing something that has no real business value. Now, in order to do that, we firstly need to understand why, and first of all, if automation is possible. So, first of all, why invest in automation? It's quite easy. This is a very nice picture you can find on chartporn.com, which is a nice website on all the possible charts you may find. And this is the geek chart that says, well, at some point we, as a geek user or a professional that wants to simply use the time we have in our working hours at best, at some point we realize that we should stop to do something that is always repetitive, the blue line, and start to automate it. Of course, automating it means that we stop doing our work. If we stop to do our work, someone that does not do automation may start to, think that he's going to win. But in the long term, he is doing something and he's spending something that is proportional to the number of things he has to do. While in our case, if we have automated everything or almost everything, at some point the time to do things is simply a constant. This is exactly what we want, because constant means usually cheap. We can easily do the things over and over again and never pay the price proportional to the amount of times we do the things over and over again. We have simply a fixed line and that's it. So, first of all, this automating help us to reduce cost. And why I'm telling you this? Because you will have to explain to your manager why after 10 days you are not even delivered any dimension or whatever. So, the first thing is that to try to understand that we need to find out what we need to automate. To reduce cost and to, again I say it, embrace changes. If we want to be agile, we need to be able to receive the changes and put the changes in place just as they happen, as fast as possible. We don't have to fear the change. First of all, then we will also have a lot of less bugs, because once we have in place a template or a way to do things, we can simply apply that way, that solution to to several kind of the same problem, several options of the same problem, and simply be sure that if I'm doing it, if you are doing it, if you are doing it, we don't produce any bug because we are using a standard way. Or maybe, yes, of course, maybe there could be bugs in the standard way, so we spread the bug all across our solution. But unfortunately, when we fix the bug one time, we just spread the fix all over the solution again. So it's something that can, usually, at least in my experience, helps to really reduce the number of bugs. And plus, what happens if we are 5 people and we have so much success that we need to hire more and more people? The problem is that the quality of the system is directly proportional to the experience of the people developing it. So I want to hire people just that are just graduated or coming out from the university, and I would like them to work as an experienced people. How we can do that? Allowing them to use tools that allows them to follow some path and be sure that that is the correct path. So again, having some automation in place not only reduce cost, allows us to embrace the changes and to produce less bugs, but actually increase the overall quality of our solution. So this is probably something that it's better to spend some time. Now, in a BI solution, we are somehow in a privileged position because it's quite possible to understand what can be automated and quite not. For example, first of all, this is easy, but just it needs to be said. We need to understand what can be automated and what not, of course. Why? Because there is something that cannot be automated, I can tell you. And I will show you what it is, and of course then we'll work on everything can be automated. Other things that we must do is that we need to impose some rules. Like, for example, you must always put a last update column in any dimension you are going to create. Your dimension must be named in such way. All your ATL packages must start from a view and not from a physical table, and so on. This because will help us to make sure that everyone is using the best practices or the standards we have in our company. Everything is done so just to avoid doing monkey work. For monkey work, I mean work that has no value, that a machine can do, or like here a monkey can do. And so the truth is, the key word here is that I want people to think and the machine do the monkey work. I don't want my developers spend time doing something that brings no value in the solution. So first of all, we need to figure out what are the well-known patterns that everyone at the end somehow use. A pattern is something that comes from architecture, that then has been adopted in software development, and is basically a general reusable solution to a commonly occurring problem. Slowly changing dimension. It's a really well-known design pattern. Unfortunately, everyone, if I speak with every one of you, everyone will have a little difference in implementing it. So the idea is well-known, the implementation might be really, really different. But if we are working in a team, we cannot have different opinion. Not because it's not good, it's really good, but at some point we have to start to work on your code, I have to start to work on your code, because, maybe because you are on vacation. So I need to work what you have done. And so I need to be able to immediately understand what we have done without having to figure it out. So this means that we have some standard, I need to be able to look at the things and say, oh, perfect, I understand this, so that I can be more productive. How many patterns do we have in BI? Well, luckily, there are quite a few. So we have generic HCL pattern, like to load tables, for example, to use partition, or to do incremental or differential load. Plus, we have several business intelligence patterns, like, for example, zero changing dimension, transactional fact table, and all this kind of stuff. So we are in good position. Plus, we have some specific SQL Server patterns like change the capture. It's not something that can work on, let's say, DB2. It's SQL Server specific. Change tracking is a very good pattern that we can use. Partition load or integration services parallelism. So we have several patterns that we can start to use, and it will be very nice if I can, if in a team I can say, okay, let's load that customer table, or let's load the product table using a differential load, applying a partition pattern. That will be perfect, because we immediately understand what we are saying. I know that what you are doing is something that is exactly what I would have done. So it's a standard, so everyone can start to work on it. And so we can finally start to be more engineered, more industrialized, so move from craftsmanship of software or a BI solution to a more industrialized approach to it. That's why we need to bring engineering into data warehouse. Engineering is nothing more, at least software engineering is nothing more than the formalization of software building and maintenance process. Software building is easy, maintaining it is much, much more complex thing. So we need to start to put in place some rules. Just some samples. We discussed about the rules in the workshop. We are here. I just give you some samples because we are using and viewing these rules in place in the demo I'm going to show you. And for example, one of the rules we have is that always put a last update column in all the tables, dimensions, whatever you are going to load. Always log inserted, updated, and deleted rows in a table that we always create in any solution we do, any business solution we do, that is called log.log info table. Use MD5 as a checksum when you need checksum, and we are going to discuss when we need it. Always use views to expose data and so on. So this is a very small set of rules, but just to give you an idea. So first of all, we need to define rules. Then we are going to automate everything, but of course we need to automate something that is clear in our mind. And what can be automated? Rules can be automated. Exception, of course, cannot be automated, at least if you are Italian. Just exception is really nice. Okay, jokes apart. Now, applying engineering to the data warehouse means that we have to start to split what can be completely automated. So something what is not really related to the business, and what I call the technical process. Here it is. So, in the development of data warehouse, we have at least two processes. One is what I call the business process. It's basically the data manipulation, the transformation, the enrichment, and cleansing logic of something that is very specific to the customer. The way I load invoices from the customer A and the way I load invoices from the customer B, even maybe on the same system but with several different customization, maybe not the same. Because someone has an invoice with a certain kind of information, other, of course, many information are very similar, but there are different type of invoice that I need to take care of. So, this kind of business process, so exactly the process that we put in place to model the business logic that my customer have, is something that cannot be automated, because well, it could be automated, but if we go back to the very first slide of the chart, since it's something that probably happens only on that customer and not in the other, make no sense to do the automation, because we will be in that side of the chart. What can be automated a lot, and really a lot, is what I call the technical process. So once I have modified, cleansed, processed, transformed my data, I need at some point to extract them and to put them into the data warehouse. That's it. No matter which data I'm using, if I'm loading a customer dimension, is really that different than loading the product dimension? No. We are just changing the column names and the table names. That's it. But if you separate the way we load the dimension table from the way we process the data so that it can be put into a dimension, we have two different and separate processes. Something that cannot be automated, the business logic, and something that can be perfectly automated, loading the dimension. This is exactly what we are going to automate. So this is the high-level vision. We have the OLTP system, so our sources. We move everything into the staging area, and this is a complete and purely a technical process. If I want to incrementally load a table, I don't care about the data that is in a table. I don't care if it's invoices or customers or orders or whatever. It's always the same. Of course, I do care when I start to process invoices, such in a way that I need to understand what I have to sum, what I have to subtract, and all this stuff. So, once I have the data inside my staging, I start to do the transformation phases, and this is something that is completely business related. So, it could be automated, but probably is not worth to automate it. Now, just imagine that we processed our data, and now the data is ready to be put into the data warehouse. Well, again, moving the data from the staging, and now the data is in a shape that is perfect to be fit into a dimension, for example, is just, again, a technical process. I will show you that. So, out of 3 ATL phases, I can automate 2, which is really not bad. It's 60% of time completely saved. To do that, we really must be convinced that the extract, move the data from the source to the staging, and the load phase from the staging, after it has been processed the data, to the data warehouse, has no value, is wasted time. The only important thing in BI is the transformation phase. That's it. So, let's start to show and see some pattern in action. Here, I have a lot of these schemas, I think 10 of them. Leave the schemas for when we will be back at work, and let's see the pattern in action, which is much more fun and easier to understand. The very first pattern is really the easiest one. So just, let me set up everything. They are full. Let me just do it. Get it? Okay, perfect. Here I have the script that makes sure that everything works as I expect. So let me clean up everything and let me. So this is my source data. I'm loading data from AdventureWorks. This is my source system. And in this phase, I'm loading the data into the staging. So I'm only interested in moving the data as is. I don't care about what the data is. So, for example, I want to create a staging table that will hold my sales order detail data. So I'm going to create a table exactly as is, because right now I'm implementing the full load pattern. Full load means destroy everything and reload everything. It's the easiest one. Let's do that. So I'm creating the table. Now let's move to the integration services. Load full means simply discard everything. This is a truncate table. Okay, and load everything. It's really, really that easy. Okay, here maybe you can, just as a sample, I started to put a row count, then maybe, as I said before, here you want also to store, after having loaded the table, just imagine that you have two other scripts here that store the number of rows you loaded, the number of rows you discarded, anything. But this is something that can be made much more complex as you wish, but the soul of this is just as simple as that. So if I execute this, I just did a full load table, and this is probably nothing really complex that worth any other word. So I just loaded my table. That's it, easy. Now let's start to talk about more interesting stuff. Still easy, like the incremental load. The incremental load says, well, get the maximum ID, given that you have an ID column or a datetime column that is always incremental, get the maximum ID you already imported. So in this case, I'm doing a select max, which is probably maybe not the optimum option if you have really huge table with no indexes. So you may also want to store the information about the last ID you loaded somewhere. But this is exactly the difference between a design pattern and implementation. Design pattern simply says exactly this. Let me go back 1 second to the slides. Design pattern is simply this. Get the last imported ID. How? I don't care. I'm simply telling you, get the last imported ID. You want to do a max, you want to store it somewhere and get it later, it's up to you. Just like the zero change dimension. What Kimball said to us is how, from a logical point of view, we should implement the solution to get a zero change dimension, not how to physically do it. That's exactly the same idea. So define a pattern, and if you want, also create a template out of it, an implementation template. This implementation template is probably the easiest possible. I just take the maximum value out of the table I already loaded. So just look that I'm loading the maximum value from my staging table. Now, once I have this value here, I simply make sure that when I query the source, I take all the values that has been generated after the last time I imported my data, and that's it. So again, not really something probably interesting, but surely not complex. And let me show it to you again that it works. Load incremental. Again, let me do all the cleanup, just to be sure that we have correct data. Now, this is the source. I'm focusing on a one order only. So here I have 12 rows in the source. I'm now going to be sure that also in my destination, since I already did a full load, I still have 12 rows, sorry. So this is exactly what I did before after the full load. Now I insert a new row into my source. So just a new order has arrived. That's it. So what I would now expect is that this pattern, this implementation, will take only one row out of that, because I load my highest ID, make sure that I only get, here it is, I only get the row I haven't loaded yet, and that's it. This is perfect for transactions. So if you are in banking transaction or you have something that's always incremental, this is perfect. It's perfect, and it's probably not so, it doesn't really happen so commonly, because a purely incremental pattern is not really that easy to find. It only works for transaction, basically. But it has just worked. Let me show you right now in the destination that we now have one additional column. Here it is. And it has been marked as just imported. Perfect. Now let's start to make things a little bit more complex and talk about differential load. For me, differential is the difference between differential and incremental is that incremental are only insert. I only add new rows. Differential means, well, maybe someone updated the row, maybe someone deleted the row, maybe someone inserted new row in the source. I want to replicate the same situation in my staging. So I need to understand if a row has been changed or not, if a row has been deleted or not, and so on. Let's start with the first, the easiest implementation, where we don't care about deletes, okay? Because we are loading data into data warehouse, we probably will never delete anything in our data warehouse, so let's try to figure out only what happened to rows that I have already imported, and if I have new rows or rows to be updated. So let me, again, set up everything. Stop this. Here. Okay, so differential, already have here open. Again, I'm just making sure that all the data is in the correct shape for the demo, and this is my query. And now notice that the first question is, but how do I understand if this is the source query? So these are the source data. How do I understand if someone changes this value? I don't have, in the source, I don't have any, last update column. Here you can see I didn't took that column explicitly for this purpose, because just to mimic a situation when the source is not able to tell us when or if something was changed. So what we usually do here, back for a slide for a second, is that the pattern is, well, calculate the row hash. So take all the column, calculate an hash value out of them, store it. Then the next time you will load that row, calculate the row hash again, compare if the hashes are the same or not. If they are the same, you already have the data. You don't need to do anything. If the hashes are different, you need to update something. So this is the idea. Calculate the hash, look up the existing data. So if, first of all, we need to, so at this point also take into account the primary keys, because I get the customer row, customer A. The primary key of the customer is, let's say, customer code A. Do I already have imported customer A? How I do that? A lookup. If the lookup works, means that I already imported my customer, and then I have to match the row hash. Otherwise, if the lookup fails, means it's a new customer, I just have to insert it. Easy. Now, how we can implement this pattern? Easy. Let's move to the solution. It's failing. Just, sure, I have to create the tables. Sure, and as you see here, I start to always have, if I want to implement a differential load pattern, always have a row checksum that is a binary 16, because I said that as a rule we must use a MD5 at least, plus the last update column. Good. As an implementation detail, I also want to make sure that I'm not going to use OLEDB command within the data flow, but I store all the changes into a specific table called the $changes as a postfix, and then do the merge in only one time, okay? Which is faster than calling update for every row I need to update. So again, here, just to show to you that the pattern says simply update table. I'm actually not doing an update, I'm inserting them changed rows into an auxiliary table, and then I'm calling merge, the T-SQL command merge, to do the merge, so to do all the updates or all the inserts or deletes at one time, not many, not having a lot of updates of single row, but I want to have one update of a lot of rows. So I should have created everything, just let me be sure of that. Okay, good. And let me now, first time I will load everything. I just recreated the table from scratch. This is a nice component called multiple hash. It's a free component you can download from Codeplex that allows you to quickly calculate checksum. SQL Server is not that good in calculating checksum. This is really, really well done. Implement a lot of algorithms to calculate checksum. MD5 is one of those. So I calculate the checksum, store the last update, just simply with a derived column. Do the lookup. Lookup is primary key over primary keys and take only the row checksum. If the lookup fails, so I don't find that primary key, this means that it's a new row, so I just insert into the destination. If the lookup works, I need to understand if what I just calculated is, so the checksum of the rows that are incoming from the source is equal or different from the last time I calculated the checksum on the same rows. If the checksum are different, means that I need to do something, in this case do an update. So let's run it for the first time. For the first time, I will, of course, load everything from scratch because I don't have any, old rows. So first time, all new rows loaded. Now let's try to change something. I do an update. Oops. I do an update, and I also do an insert. As a result, I will have here, this is the source of my table, I will have these two rows. This has been changed from 2000 something to 1000, and this is the new row that has been inserted. Good, so I expect two rows to be detected by my system. Let's see if it's true. Execute it. Ah, good. Of course, he processed it has processed all the rows, because there are no way to understand in advance if something is changed or not. But the result is that the destination table had only one insert, the new rows, and one insert into the commodity table, into the auxiliary table for the changed rows. After having done that import, I also called the merge statement that I have created in order to simply do the merge. So move the data from my changes table into the real destination table. Again, I'm matching here on the primary keys and just updating what I call the payload, so all the columns that are not keys. Now, you can start to guess that this approach will be always the same for all the possible tables. The only thing that will change is the primary key definition, the payload, up to here, because these two columns we have said that are mandatory, so all table will have this column for us, and of course the table names. So this starts to get a little bit interesting because this means that can be automated. Let's see if I really updated my staging table too. So I expect to have just one row in the changes table because the inserted row has been directly inserted into the correct destination, the final destination. And here it is. This is the row that has been changed. This is the calculated checksum. And of course, if I now check in my final destination table, I will have that two rows has been inserted in the second batch. Good. So this is a nice way to do a differential load. Of course, this is maybe resource consuming because we need to always load all the rows from the source because there is no way to ask to the source, give me only the changed rows. But maybe a way that could be if a row, if the source, for example, exposes a timestamp column. Because if I have a timestamp column, I can simply get rid of the hash and use the timestamp to ask to the source, can you please give me all the rows that has changed so as a timestamp or modified date value that is greater than the last time I imported everything? If yes, this will work perfectly, and I have here another demo too that you can use. I'm not doing it right now because it's very similar to this one, with the exception I'm just showing you the demo, the logic of the demo. Just let me create the correct objects so that the package won't give any errors. Here it is. The only difference here is that when I query the source, first thing I have to do is get the last loaded timestamp. So I query my staging table or my auxiliary table where I store, to avoid again the max usage, the last loaded timestamp. I simply execute a query that takes my modified date from my staging table. And then the only difference here is that in the source I put where, and that's it. So in this way, I can only get the 2, 3, whatever rows that has been changed after I imported everything. And then everything remained the same, almost the same. Now, the problem here is that I cannot detect deleted rows, of course. So in order to detect deleted rows, because of course they are completely missing from the source, so they will never will be sent to me, what I can do is use the change tracking system that comes with SQL Server. SQL Server has 2 ways to allow you to understand what has changed in the source table. One is called change the capture, is probably the most complete and full functionality that allows you to understand what's changed. Matt Mason, one of the developers of integration services, has a really nice blog post on that guide you step by step to implement this. But in some cases, this is just too complex or too heavy to be used. It uses the transaction log behind the scene, it creates a job, it has some complexity. Maybe you only want to understand if a row has changed or not, and not the track how it has changed during the day, for example, which is exactly what change the capture does. You are only interested in, at the time you are loading your data warehouse, to understand what's changed, not how many times it has changed during the day. In that case, the change tracking is perfect. It's really underused feature in BI, but it's really lightweight. It's weight like an index, so it's not really performance killing. And it's really easy to be set up. Let me show it to you. This is a demo I'm going to do. And let's stop everything again. Let me show and take the correct script. Here it is. So let me set up everything again correctly. Here it is. Let's move to AdventureWorks. Make sure that everything is set up for the demo. Good. Delete the rows I inserted before. Okay, now we are in this situation you will find when you open a fresh new AdventureWorks. I'm going to create an auxiliary table where I have to store change tracking info, because each time I ask for a change tracking data, I get a version number that I have to store somewhere. And so this is my source query I use one. Again, the same source. I'm going to create my tables, and now, again, details with the changes. And now with the changes, I have one additional column, change type, because change tracking is able to tell me, hey, this row, this primary key has been updated or has been deleted. So I can detect the 2 changes. I can, with the pattern I used before, with the implementation of the pattern I used before, I was able to detect insert and updates. Deletes were somehow problematic. Now with that, I can detect also deletes. So when I store everything in my $changes auxiliary table, I have to store also the information about that row. Is that row has been updated in the source or has been deleted in the source? So I can decide what to do in my staging or fact table. That's why I need this additional column. Now, I should have created the table. Just let me check it. Good. So let's alter the database in order to enable change tracking. I'm doing it on the source, of course. And now I'm switching to the source and enable the change tracking on the specific table I want to monitor. And now I'm going to do, of course, a first load. So I'm starting to load my table for the very first time. Here, we need some logic. For example, I need to understand what is the last version I loaded. The first time, I don't have any last version loaded, so I put -1. If I put -1, I want to do a full load, so that's why here it's really useful to start to use expression with constraint. So if I never loaded anything before, I want to do a full load. Once I loaded everything, I need to store the version I loaded now. How can I get the version I'm loading? Get current version. There is a specific function for that exposed by SQL Server, change tracking current version. So I need to store the version information in my storage, in my staging database. I do that, so let's do it for the first time. Good, full load, 100,000 and more rows, perfect. And I also stored my, my load version. Let's see it. So let's see that in my change tracking info, now I have my, oops, let's move to the core database, ATL automation. I have my load version 18. It's a number, don't care about the value you have here. And of course I have my staging table loaded, good? Now, let's start to change some data. Let's do an update. Oops, on the use automation. Let's do an update, good. And let's do an insert. Now, if I execute the package again, I expect to go to that branch because it understands that I already loaded the data. So I need to ask to SQL Server, can you please give me all the data that is a version higher than the one I already loaded? So how can I do that? Differential load, open the query, here it is. There is a specific function called change table that allows me to ask to SQL Server, I already have version 18. Can you please give me all the rows that has been changed and so marked with a higher version number? That's it. Of course, this question mark is because here I'm using parameters, okay? I suggest you not to put all the query inside this box, but create stored procedure or views that allows you to be much more productive when maintaining the code. But just for demo purposes, I put everything here so I can just ship the package to you and you can play with it. So everything is self-contained. So let's execute this. I expect 2 rows to be detected. Good boy. So 2 rows. 1 new row has been inserted. 1 row has been changed. Good. And then I apply the same logic before. I do the merge. Perfect. So let's see if it really worked as I expected. I should have 1 row in the changes table, and this change type is U. This is something that also you can ask the SQL Server to give you. What kind of change happened to the row? It gives you U, D, and I. Insert, delete, and update. Easy. So here is the updated row. And so if I look at my reference order, I can see here that the 2 rows has been updated. So this where all the value were loaded before, so no last update value. And here the 2 rows that has been updated in the last batch. Now, what is the version we have right now? 20. Basically, each transaction increased the version number by 1. So we did 2 transactions, 1 insert, 1 update. So that's why we are at 20. Now let's delete something. I'm deleting the new row I just inserted before. So now I don't have, I should delete, oh yes. So I delete from the source, the row I inserted before. So the one with a very high order ID, says order detail ID. And now, of course, let's see what happens if I execute my process again. I expect only 1 row to be detected perfectly. So no new rows, only 1 changed rows. Let's go to the change table again. 1 deleted rows. Of course, I only have the primary key for that row because since it has been deleted in the source, I only have the primary key of the deleted row. I don't have all the other columns. This is, for example, a big difference between change tracking and change data capture. With change data capture, since I'm reading the transaction log, I also have the deleted values of the rows. Here I only track, the system only tracks the primary keys, which for me, it's enough in this case. So what I have to do is simply do a merge, taking care of doing something with the delete. So for example, when rows matches and change type is D, in this case, I also physically delete the row in my staging. Maybe if this were not a staging table, but a fact table or a dimension, I would have marked the row as deleted instead of physically deleting it, of course. So just let me check that everything worked as I expect. So even in my staging table, I should not have anything here exactly. I don't have my high sales order LED row anymore. Good. Now let's move to something more complex, like for example partitioning. With partitioning, basically you have to do something like that. I'm not going to show you the demo, but you will have the package that works and load 1 partition at a time because it's only implementation logic. The partitioning idea. Here it is. I have many patterns that you will find in the slides. I'm probably not able to touch them all today. Partition load is very easy. Create a partition if the data you are starting to load already doesn't have a partition on their own. Create a switching table, load the switching table, switch the partition, drop the switching table. It's as easy as that. And the physical implementation of this is exactly that one. First of all, we need to understand which table we are working on. Check if the partition exists. If it doesn't exist, create a partition. Then do something specific for SQL Server, like get partition number, drop the switching table, create the switching table using a nice tool that is again available on Codeplex and is called Manage Partition, that automatically create the correct staging table for you with the correct constraint in the correct file group and whatever. So it automates a lot all the T-SQL you should write alone in order to be able to do the switch in and switch out working correctly. We load the partition. Actually, we are not loading the partition, but we are loading the partition, correct? So we are going to load a partition that it changes every time. So if I'm loading the 2005, I will have a table that is called sales order 2005. If I'm loading the 2008, I will have a special table that is created for me by the tool called the sales order 2008. So the name of the target table will change depending on the year, if you are loading by year you are using. So that's why here we need to use a variable name. Here is the parameter that takes the year you want to load in this example. So if you change this year, it will load for you the correct partition with the correct year. Now, this is easy because I'm not showing the demo because partitioning is something that should be well known. So you can really find a lot of partitioning of white paper and documentation on partitioning in the internet. This is simply the implementation of that. What I would like to show you is how to do parallel work. So let's say that, for example, we want to load not one partition at a time, but 2 partitions at a time, 3 partitions at a time, 10 partitions at a time. So we have something that we want to do, and we know that we have to do it for many times. Maybe because we are loading, we are partitioning by customer, so we have to load customer 1, customer 2, and so on. Maybe because we are partitioning by year. And the trick is that on my machine, on my development machine, I can afford, due to resource constraint of my machine, only to load 2 partitions at a time. But the production machine is a fast-track data warehouse where I can load up to 16 partitions at a time. So how can I create something that I just turn on and off and say, okay, let's move from 2 to 16 or 8 or whatever is the correct number to use all the resources my machine has? This is the pattern. I create a package that doesn't even know that he will be executed with many other versions of the same package. So I simply create, first of all, here, partition. Pardon. So I'm creating a table called Q. Here is, it's a very simple table that simply says, okay, I need to load customer 1, customer 2, customer 3, and so on. What I would like to do is create a package that executes this very simple query. Let's say, okay, what is the first customer that I should load? I'm free to do something. What is the first thing I should do? Well, let's take the first customer that has not been yet taken by anyone, so where task start equal to null. To do that, to avoid locking, you can use this nice trick. Update set where task start is null, set start to something, output 2. This is basically allows you to get the result of your update. So you don't have to do select plus an update that may cause locking or deadlocking if you don't use update locking. So basically this is the algorithm. Let me show it to you. So each time I execute it, now just imagine that I gave the customer 1 to one task, next customer to be executed customer 2, and so on. So just imagine right now, and this is my queue. So in my idea here, I have 2 packages working. that one is loading customer 1, other is loading customer 2. Now, reset everything. Of course, when in this package, now it's only in my mind, will finish its work. Since it has taken the customer 1 with ID 1, it will simply update and say, okay, I finished my task at that time and update it, and that's it. So let me clear the queue, show you that the do work package simply use the same logic I defined before to get the first customer that is not used by any other packages. Then do something complex, and then set the work done. This will be done forever. Forever means until there are no other customer to be processed. So I have one package that does an infinite loop, where infinite means when there is nothing more to do. What I would like to do right now, and this will work perfectly, I can do right now 2 things. I can execute this task with DTExec as many times as I want, just running it, because he alone is able to get the first customer that need to be processed and process it. Finish the processing, get the other customer, and so on. So alone is able to do anything. I don't even have to pass any parameter to it. So I can simply from the command line execute DTExec as many times as I want, calling the same package. If you in production you are not allowed to put your end in production, and so you just have to give a package to someone and say, okay, this is the package, run it many times, and maybe he said, oh, I don't know how to run it. So you have to give me a package that execute as many packages in parallel as you think it's good for my production machine to use all resources. Since I'm not an integration services expert, I just need one entry point, one parameter, that if I see that the 2 is too low because I'm parallelizing too few, I just want to turn it up to, let's say, 16. Okay? This is my orchestrator. Basically, you see, I call the package as many times as I want, simply getting the parameter here that say, okay, execute the package 8 times in parallel. Here I have a lot of small constraints that say, okay, you will execute this do work 1, execute package task, if and only if the max parallel task is something that allows me to execute 1, 2, 3, 4 packages together. So let's start with 2. Okay, let me execute this. Let me show you the query, the queue. So excuse me. So this is the queue. It's completely empty. The tasks are waiting to start to load the work. Here it is. Let's start the orchestrator, and you will see that only 2 tasks will get executed. Okay? Here you will see that slowly, each package will do some work, finish the work, start to ask, there is other work for me, and so on. Now, of course, this will take some time since we are only, using 2 tasks, and that's it. Now, I'm back to the, guy that is not a integration services expert. Say, look, but this machine is not using all my CPUs and memory. I want to, turn to a higher level the parallelization. So I just hit here 8. So I move to 8 parallels processes altogether. And this is now using 8 parallel things together. And here, of course, the queue is working much more faster. So now just imagine that basically this something complex can be anything. Anything we already saw. Maybe it could be load the partition. Maybe it could be load something else. But this is a pattern that can be applied to other pattern that allows me to load anything in parallel. Now, you will also, let's move to now the other interesting stuff that is, you have much more slides here that shows other pattern like also how to load a fact table. It's actually a pattern, but it's really easy. I'm not going to show you because also we will automatically create a package that will load the fact table for us in a couple of minutes. But this is the idea how we do usually create a fact table. Once the data is ready to be put into the fact table, so we have already, shaped the data, transformed the data such in a way that it's ready to be put in the fact table. The only thing we have to do really is get the business key, look up the business key to the dimension, get the surrogate ID, and that's it. And do this for all the dimension that this fact table is using. That's it. Of course, I'm supposing that you are going to use a Kimball approach or something like a Kimball approach with a dimensional modeling. So you have facts and dimension, of course. There is a nice pattern also to load zero change dimension type 1 and type 2. I'm not going to describe it, we are going to see it in action. But again, this means that if there is a pattern, this can be automated because only the name changes. So let's talk about automation a while. And what I would like to show you, for example, is automation is all about metadata. And this means that I need at some point to be able to, for example, query my system. In this case, okay, good. Let me create a view. So let's say that I have, as I said before, I have a rule that says all the data that must be loaded into my system should be exposed through view. So this means that I have a set of views that I can query, and maybe my views exist in the BI schema as an additional rule. And say, okay, this I can query, in this case, the metadata available directly from SQL Server using the DMVs. And I say, okay, can you please give me all the views that I need to create, all the views that you expose me from the source so that I can create all my staging table, I can create all my packages so that I can, let's say, for example, full load all my table. Now, to do that, one very nice tool is called BIML. BIML is, here it is a kind of a specific XML version of XML that allows you to tell to Visual Studio, in this case, what you want him to do. So, for example, let's use this. BIML is again something you can find on Codeplex. You just have to download a tool called Business Intelligence Development Studio Helper. Here it is, and you can find it on Codeplex. And this tool allows you to use this BIML language, where, as you can see, you can define how your package should be created for you. Like, for example, I want in my package 2 connections. One to that connection string, one tied to the connection string. I want to create a package with that name. In my package, I want to have some variables. In this case, variables named loaded rows of integer type. Then I want to add tasks, an execute SQL task that does a truncate table. You remember the full load pattern, truncate and load. Then I have a data flow. Okay. The data flow simply takes the data from my view that I can discover through my small metadata I just showed to you. And I would like also to count rows, and then I also want to put everything in my destination, that is the staging, in this case person to person, so a table with the same name without the VW prefix that exists in my staging schema and my staging database. So this means then I can generate SSIS package, and I get the package created in a couple of seconds. Okay, here it is. Good. This is exactly the pattern of my full load. Now, what is interesting? That template can become something scripted. Like, for example, here it is. I can add some C# to my BML, and of course I can say, okay, this, you remember the query I showed before, so select head view name, staging table name, so I can extract the information about all the views that I have in my source. I can, since I had some rules in place, I can also automatically generate the table names, and if I want also physically the table, I can generate automatically. And I simply execute, I use this C# extension of BIML that says external data access, get data table. So basically what I'm doing here is executing this query, and I want to have one package for each of that row created for me. Of course, using the specific view name, table name, one for each row. So the result is that basically I'm asking BIML to, I can stop this and close this. I'm asking BIML to create for me a lot of packages, because I'm enclosing the package attribute in a for each statement. This is C#, this is BIML. It's somehow confusing because there is no syntax highlighting. BIML has been done by a company called Varigens, and of course they sell also the ID, so the integrated development environment. They have made their language public, and they sell the tool to better deal with that. But it's not strictly needed. So with that tool, you can do really a lot of nice stuff. You will have IntelliSense, you will have syntax highlighting, but actually it's not needed. You can do that only using Visual Studio, and this is very nice because it comes for free. And look at what happened when I do generate scripts over my generate package using my script. Here it is. I have all the pattern, the full load pattern applied to all my tables for me. Now, if someone comes to me and say, can you please add one table? Can you please change the pattern? Can you please do this and that? Do I care? No. Really? Is that easy? I mean, how much time I took to do that? 1 second, let's say 5, let's say 10. Of course, we need to have a well-defined set of patterns and templates in our company, so I can just pick the correct template and apply it. It will take some time to do that. These are samples. You can start from that samples and customize it with your need. But then it's really that easy. Now let me show you something even more interesting. Let's say that we want to load. We did everything, so we moved the data into the staging table. We did the processing. We shaped the data such in a way that now it should be only put into effect table. Now we could create also the dimension using BIML, for example. Let me create this zero change dimension type 1 package for you. Okay. Yes, here it is. So here I applied all the pattern you can see then in the slides to load the zero change dimension. Of course, this may become a little bit more complex because dealing with the zero change dimension type 1 and type 2 can require some if logic or something a little that make your life a little bit complex with BIML. So maybe you can also resort to C# only and create your own tool. I will show you one if I'm not too late. But I think this is important for you. We like that. And what we can do is also completely create a fact table from zero, because this is basically the template of loading a fact table. As I said before, is load the source and start to do all the lookups. Again, if I have a table that lists for me not only the name of the fact table, but all the columns that are used in the fact table, for each column I can do the lookup to the appropriate dimension. I only need to have a table of metadata that I have to create by myself. Let me show it to you. Oh, sorry, it's here. Here it is. Let's say, okay, if you are loading the view fact orders, just remember that the big key store column should be mapped to the dimension store using that column. That's all we need to do a lookup. So again, and now you can figure it out yourself. I can do a for each loop over this data, and instead of creating packages, within a package I create a lookup. Let me show it to you. Fact load script. As you can see, when you have something more complex than a full load, even the script becomes a little bit more complex, but once you get used to read it, and of course to make good use of comments, it's all quite easy to understand. For each columns, my dimension, do the lookup, and so on. Here you can read how can you also do the mapping within the lookup to say this column, go to this column, and take the surrogate key for me. So let me execute this. Okay. Here it is. Effect load orders wallet. Now, if I need to add a new column or change something, I can easily change the package. Of course, then maybe I need to reload the fact table, but that's completely another story. It's due to the data. I don't need to do anything specific to change complex packages or whatever. The packages are loaded and created for me. So this is really the power of automating anything. Now, BIML can be used to automate a lot, but of course it has its own limitation, because when you start, for example, to need to ask the user interaction, for example, I want to create a dimension. I need to ask to the guy who is creating a dimension, what is a zero change dimension column? This column is type 1, is type 2. So in this case, you may find yourself in a better shape if you create your own tool. Because integration services are a really nice tool, but mostly is a framework. You can create your own tool that creates create packages for you. Let me show it to you. Now, following my rules so that I expose everything to view, here my little tool queries the system catalog, show me the views. For example, in this little sample I have only customers. Here you have to choose what is the key that is basically uniquely identify a customer for me. It's only the customer code in this case, good. And then, since in my customer dimension, I not only have first name and last name, but I also have information about geography. The information about geography, I want to make them a type 2. So I simply select that these are type 2. So this is where BIML is not really helpful, because it cannot ask for user interaction. So or you do everything within the metadata, and then you do all through BIML, or if you need or want to ask user interaction, you need to do something on your own for now. Once I have done this, I can simply say, okay, just let me make sure that everything will get created correctly, generate. In 2-point-something seconds, the pattern defined before has been implemented for me. And this means that this is what I got as a result. Here it is. Control-C. Look at how complex it can become to deal with slow change dimension type 1 and type 2 within the same dimension. Now, this is the really important stuff. I don't really care that I spared a lot of money because in only 1 second I created anything. That's good, but not enough. What I really care is that anyone in my team, no matter how much experience the developer he is, can do something like that, which is perfect for me. For my team, this is what we consider perfect. Okay? It's not the perfect thing, because there are some, for example, dimension, let's say the customer dimension of a telecom company, that cannot be treated automatically. But it's one dimension out of 20. I can spend much more time dealing with that specific dimension if I spare time doing things with all the other dimensions. Okay? So that's the trick of automating everything. So, I think I'm too much late. So, you can really have a lot of things here. I put much more slides than what I would have known, I could have showed to you, but so that you can also use it in your office. I think I showed everything to you. The tools, so the BIML, the MIST, everything. How you can create your own application. Everything I showed to you, you will get in the demos, scripts and stuff. Some information about you can create your own package generators. And that's it. Thank you very much. I hope you figured it out. And if you have questions, I'm here. Thank you very much.